So here we are at a solar field in the winter, and these rows are not tracking right. Should all face the same way. Should be more upright now too for the time of the day. So yeah, these single axis trackers are the most common form of tracking system, especially for the Midwest. And it's pretty common for them to have little issues coming out of alignment with each other. This ATI is probably the best because it's just one line and down the middle and they should all stay the same. But other ones have different motors and trackers for every single row. Those get out of alignment all the time because each one operates independently. Whereas this has like 30 rows, all should work together. But what I'm real excited about is agrivoltaics and how you can farm on the inside of these solar arrays. It's a lot of space. And thinking a lot about those sort of urban farms that I've seen a lot online, like what's his name, Curtis Stone, other people. There's probably so much you can do, like in between the rows and everything. And there's all this space over here. Instead of doing a commodity crop like corn or soy, you could do more like high value market crops like, vegetables. And it's more hands-on work, but it employs more people and is actually like real food instead of like highly processed corn or soy. Might be for animal feed or high fructose corn syrup or ethanol. And if you want to just do hay or pasture, and the most common thing really for agrivoltaics is to bring the sheep into the site, let the sheep graze it and keep it low. And you can plant the perennial pollinators and have, beautiful prairie. It's good for the water table. It's good for the insects and overall surrounding ecosystem. It's a little oasis for the surrounding monoculture to have, source of pollinators and a little bit of water, local water infiltration and filtering from the perennial prairie. And what I'm real excited about is kind of like the next generation of robot lawnmowers. It's going to be all electric farm equipment that's automated, solar powered. It'll have a low profile so it can go under this. Because it can be, actually what I want to do is basically put wheels on a solar panel. And it'll be the wheel is probably the tallest part. So that the whole thing is maybe like 16 inches off the ground. And it's just like a solar panel. It's the actual frame of it to give it like a good wheelbase, and then just have like attachments that attach on it and stay low, so it can stay low and go under stuff. You can have like a small lawnmower blade, thermal camera, ultrasonic sensors, a soil sample tester with like a spectrometer, so you can take soil samples and then analyze all sorts of things. But I'm interested in the carbon credits. Ultimately, the same thing could be used for environmental restoration work. The most common form of carbon credit up to this point has been for ecosystem restoration or ecosystem conservation. So they set aside land and the rainforest and get carbon credits for protecting it. But the problem is that they are not monitored. So it's happened, many times that they issue carbon credits and then they cut down the forest, and the credits were given for something that isn't true anymore. And so that really is a stain on the reputation of all carbon credits. And there's many other types of ecosystem restoration projects that you could use an autonomous rover to do like continuous site monitoring and put a timestamp and a geolocation tag on soil sample tests. The other thing I've heard is that soil sample tests can be highly subjective because the person taking it probably knows something about how to identify a good location for a soil sample test and a bad one, and so somebody can kind of selectively take soil samples and skew the results. But what you need to do is like geotag it and come up with some scientific process to have an objective reading, samples spread through certain, quadrants or something like that. And it should be an equivalent to like a revenue grade meter for solar. So you can do like a scientific, empirical estimation of how much carbon's been captured in the soil. And there's many other applications. Really, autonomous agriculture is going to be phenomenal. And I imagine a fleet of small solar-powered equipment will be able to replace large tractors that are mostly just used to pull and tow stuff. So imagine this. It's basically like all of your farm equipment, instead of being towed by a trailer or a tractor, it's like the farm equipment itself will just be motorized. I was imagining this whole setup where you have basically like a big barn for your fleet of automated rovers, and there's all these different attachments and like a 3D printer kind of like bay, and the fleet can pull into the bay and then get like reconfigured. So the way these little automated tractors will work is it's like a frame, and you can extend the wheelbase or make it taller. And so it's very modular to be any kind of width and any kind of height. So you can make it span over tall perennial bushes and do perennial harvesting with different attachments. It can have like, you can have like a something to cut and bale hay and all sorts of different attachments. And in this way, you can have like a fleet of these things that are kind of always operating. They're self-powered, and then they can go to like this bay and be reconfigured autonomously. So, yeah, dude. Next stop is farms in space, O'Neill cylinders, replacing all these millions of acres of monoculture with, um, monoculture in space. That's fine. Got no problem with monoculture in space, but yeah, no, we want to restore the prairie and bring bison back and have it just like one big vast, um, biodiverse, vibrant ecosystem on Earth. Um, we can have agroforestry, perennial polycultures that are beautiful and very productive and provide lasting permanent value to generations. It's like once you establish this kind of perennial agriculture, it's really a fail-safe for unknown circumstances for the future. If our children inherit this land, after some calamity, we fucked it up real good with all these chemicals and killing everything, just having bare dirt. So, I mean, if we restore the ecosystems and restore the soil, and it's all like a permaculture, food forest landscape, then even with like minimal maintenance, there'll be a lot of opportunity for anything that's alive. But we basically turned the whole Midwest into this Dust Bowl desert, and we're making the deserts all spread out. Oh yeah, the other thing is this agrivoltaics, the shade. It traps more moisture in the soil, which we got plenty of moisture here, so no big deal. But in semi-arid conditions where there's desertification, the desert's spreading out, and so what used to be kind of mediocre land is now actually fully desertified. And you could put agrivoltaics out there, and you know, you don't even need to do this, but bringing water out to wash the solar panels contributes more water. And basically, you can turn a desert into a lush grasslands. And with just a little bit of permaculture design, you could really spread that to really vast landscapes, to transform desert to green landscapes. Yeah, and with power, I mean, you could desalinate water. There's a whole way of using electrolysis to make hydrogen. So you could use salt water from the ocean as your main input to be making hydrogen. And then when you recombine the hydrogen in a fuel cell or a turbine or another type of electrochemical process, when you use the hydrogen, it often will recombine with water, and you end up with water, or hydrogen and oxygen in a fuel cell or turbine is going to give you water. So you got fresh water as the exhaust of your energy storage and your chemical process inputs. So yeah, water in the desert's a precious thing.